All right, we're going to look today at what's called reflectional and rotational symmetry. So two different types of symmetry and also point symmetry, okay? So you've probably learned about symmetry. You might already know most of this, honestly. Certainly line symmetry you should have done at some point, maybe in middle school or even before that. And there's just some definitions here for you, some things to look at. So basically, in bold at the top, it says, to carry a shape onto itself is another way of saying that a shape has symmetry. So perfect example, the green shape right there you see, that has a line of symmetry. Why? Because it can be carried onto itself. See this right here? This line right here? If you were to fold along that line, you would fold along that line, right? You would get that shape to land right on itself, okay? So if you can get the shape to land right on itself, then it has a line of symmetry. So some examples here. Here is line symmetry right here. The letter A has line symmetry. If you go right down the middle and you fold the letter A, right? You fold the letter A, it will land right on itself. Z does not have a line of symmetry. No matter how you try to fold it diagonally, horizontally, vertically, no matter how you try to fold the letter Z, you're not going to get it to land on itself. You could do that by physically folding your paper to see and look at it and see, wait, yeah, you're right. He's right. It doesn't work. Okay? So no line of symmetry there. You got one line right here for a butterfly. Nothing here. You got 6 lines of symmetry for this flower because this flower has 6 points to it, and you could see all the lines drawn there. 4 lines of symmetry for this square. All squares have 4. You can go up, down, up and down, and then you can go diagonal, diagonal. So there's 4 lines of symmetry, 4 different ways you could fold a square onto itself. Nothing here and nothing here. All right, some examples here, how many lines of symmetry. So I want you to pause the video. Based on what we just talked about, you should already know this. How many lines of symmetry, fill those in, and then just watch the video to check yourself. All right, so make sure you've tried them. How many lines of symmetry? This one just has 1 line of symmetry right here, right down the middle there. All right, so 1 line of symmetry. How many here? You should have 1, 2, 3. So you have 3 lines of symmetry. This one has 2. Okay, so 2 lines of symmetry there. The letter B has just 1. All right? The maximum lines of symmetry a polygon can have is the number of sides. So here's 2 examples. I gave an octagon and a pentagon. Okay? So the octagon has 8 sides. Guess what? 8 lines of symmetry. The pentagon has 5 sides. 5 lines of symmetry. That's only going to happen when they're regular, regular meaning all sides are equal length. If you have regular polygons, you will have that max. So a regular pentagon will have 5. A regular hexagon is going to have 6. A regular octagon has 8. If it's not regular, you may not have that many. It may be less. It will be less if it's not regular. You could still have some, but you would have, if it's not regular, you could have less. Rotational symmetry. Now, what's rotational symmetry? It's a little trickier, okay? A geometric figure has rotational symmetry if the figure is the image of itself under a rotation about a point through any angle whose measure is strictly 0 to 360. So if you can rotate it around a point, usually the point in the center, okay? If you can rotate it and have it look the same, then it has rotational symmetry. Doesn't have to be totally upside down. You could rotate it any which way and it would have rotational symmetry. So, like this blue figure here, this blue little, what are these things called? Mesmerized things, okay? That has 120 degree rotational symmetry. Why? Because you could turn it 120 degrees and it will look exactly the same. Turn your paper 120 degrees, it'll look exactly the same. Then turn another 120, it'll look exactly the same. Turn it another 120, and you're back to the way where you started, because 120, 120, 120, 3 120s is 360. If you rotate 360, you're exactly back to where you started. Okay, so the order is 3 because you could do it 3 times. 3 120s is 360. So 360 divided by 3 is 120. That's how it's always going to work. How about the letter S? The only way to get the S to look the same is if you rotate it upside down, and that's 180, right? So 180 rotation, and that's an order of 2. Why? Because you can do it twice, boom, and then boom, again, right? Flip it upside down, and then flip it upside down again. You're back to where you started. However many times it takes to get back to where you started, that's the order. That's the order. Look at the recycle symbol, okay? You can rotate it 120, and then another 120, and then another 120. 3 times. 3 120s is 360. That's why the order is 3. That's the same as this one here. And then a parallelogram, in order to look the same, you'd have to rotate it upside down. So it's 180, and the order is 2. All right? The order, oh, here it is right here. We just talked about it. The order of rotation symmetry, the number of positions in which the object looks exactly the same. So however many times you can rotate it to have it look exactly the same, that's the order. All right, so how many ways can you rotate this guy here, this symbol here? How many times can you rotate that to look exactly the same? Well, you can turn it, you got to turn your paper to see it. It's tough to do on the video, right? But you could turn it 3 times. 1, 2, 3. So the order is 3, and that means the angle of rotation is 120. How did I get that? Well, you find the order, and you just do 360 divided by the order, and that's going to be 120. So you get the angle by taking 360 divided by the order. Same thing here. This symbol here, this refresh symbol, right? That's a refresh symbol, and or recycle, kind of like a recycle symbol. The refresh symbol, you can turn your paper 3 different ways and have it look exactly the same. So again, the order is 3 and the angle of rotation is 120. Whenever the order is 3, the angle will be 120. And you're going to rotate around that point right in the middle, right? That point there, that point there, that point there, and that point there, right in the middle. How about this star? How many different ways can we rotate and have it look exactly the same? Again, the point's got to be pointing up. All right? You can rotate it 1, 2, 3, 4, 5. There's 5 different ways to rotate it and have it look exactly the same. So it has an order of 5. So what's the angle of rotation? Well, it's just 360 divided by 5. And that comes out to be 72 degrees. So my angle of rotation is going to be 72 degrees to make it look exactly the same. So you rotate it 72, it looks the same. You rotate it another 72, it looks exactly the same. You rotate another 72, it looks exactly the same. You do it 5 times, you get back to 360, which obviously looks exactly the same. How about Z? Well, Z can be flipped upside. I think we already did Z, right? Yeah. Or we did S. Well, S and Z are the same thing, just flip-flopped, right? So Z, you can flip it upside down, and then you can flip it upside down again. So there's 2 different ways to have the Z look the same. So that's 180-degree rotation. A few more here. We have this clover here, all right? And there's 1, 2, 3, 4 points, basically. So there's 4 different ways to look exactly the same. And then 360 divided by 4 gives us 90. Okay, so the angle of rotation is 90. This one here, there's only one, because if you flip it upside down or rotate it upside down, the arrow's pointing the other way. That's not the same. It's got to look exactly the same, right? So you really can't do anything with the arrow except there's only one possible way. So really their head doesn't have any rotational symmetry. So it's 360. How about this orange slice? Well, you got this piece up here, right? This upside down triangle like that. You can have this one at the top. 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 This one, and this one. So there's actually 1, 2, 3, 4, 5, 6, 7, 8. There's 8 different pieces of the orange you could have at the top. So you could just keep rotating it 8 times basically to look exactly the same. The order is 8. I do 360 divided by 8, and I get 45 degrees, so my angle of rotation is 45. What am I rotating around? I'm rotating around the center of the orange right there. Rotating around the center. And then this one here, you could rotate it upside down. It'll look exactly the same. So that's an order of 2 with a 180-degree rotation. And the last thing I want to talk about here quickly is point symmetry. Point symmetry exists when a figure is built around a point such that every point in the figure has a matching point that is the same distance from the central point, but it's in the opposite direction. An easy way to test for point symmetry is, it's very simple. You rotate it upside down. If it's 180 degrees, if it has a 180-degree rotation, it has point symmetry. So that's the best way to do point symmetry, is basically flip your paper upside down, rotate your paper upside down. Does it look exactly the same? Then yes, it has point symmetry. All right, so S, if you rotate your paper upside down, do it now. Turn your paper upside down. Does it still say S? Yes, it does. It has point symmetry. Look, this regular hexagon here, rotate your paper upside down. Does it look exactly the same? Yes, it does. It has point symmetry. This next little, whatever that thing is there, rotate your paper upside down. Does it look exactly the same? Yes, it does. It has point symmetry. Same thing for this purple parallelogram. Rotate it upside down. Does it look exactly the same? Yes, it does. It has point symmetry. So all 4 of those have point symmetry. The order is 2. So if it has an order of 2, it has point symmetry. You'll notice actually with any even symmetry, it will have point symmetry. Any even order will have point symmetry. All right. So what we'll do is look more at point symmetry, rotational symmetry, and line symmetry in class tomorrow. You got a bunch of different examples we're going to look at, try to determine what type of symmetry does it have. Line, point, rotational. All right, what kind of symmetry does it have? I'll see you then.